So, good evening, everyone. My name is Carlos Hine. I work for General Electric in the Power and Water Engineering Division here in Greenville. And my project focuses on improving the reliability and availability of a water delivery system that's used with gas turbines in power plants. So a little bit of a history and background. The water system used in gas turbines, it's used to mitigate exhaust emission, particularly carbon dioxide and nitrous oxide. So the history of this system has been various failures with one component, one key component, the flow meter. Right? It's a fairly inexpensive piece of it's a device that's used with the system. However, the impact is pretty significant. It pretty much renders the whole system inoperable. And as a result, the plant cannot meet CO2 emission compliance, and the whole plant has to back down on load output by about 40%. So that's a significant impact right there. And as a result, there's liquidated damages, right, to the owner of the plant, to my customer, and that could be significant, of course. And as a result, the customer's not very happy. So looking at the problem, we found that the legacy meter had rotating components, impellers and bearings, a very delicate piece of equipment in a rugged environment such as a power plant. So that was the main cause of the problem. And by the nature of the design of this component, we had to design redundancy around it to increase the availability of the system. So that calls for extra hardware, if you will, in the system. Right? So looking at the alternatives, so we focused on these four main key attributes. First, no rotating components. We wanted to maintain or improve the precision and the accuracy of the component, looking at design simplicity and the cost, obviously, and how available the new device was. So we did a trade-off, and we picked one design and applied it. And as you can see in the sketches here, by having a design with no rotating components, redundancy was no longer required. A lot simpler design around the one component. And as a result, the reliability increased by about 60%. This was, of course, a direct impact on power plant full load availability and emission compliance. And in addition, we were able to save about $250,000 in direct material in the next 2 years since the design was applied.
And your implementation